Hey everyone, welcome back to Mind Masteral. This question is based on Class 11 Chemistry, specifically Chapter 2, Question 2.2. Let's break it down step by step. Part 1. Calculate the total number of electrons present in 1 mole of methane. First, let's calculate the total number of electrons in 1 mole of methane molecules, ch-4. Methane has the molecular formula ch-4. In 1 molecule of methane, there are 4 hydrogen atoms, each contributing 1 electron, and 1 carbon atom, contributing 6 electrons. So, total electrons per molecule of methane, charge 4 from hydrogen, plus 6 from carbon, charge 10 electrons. Now, we need to find out how many molecules are there in 1 mole of methane. Calculation. 1 mole of any substance contains Avogadro's number of particles, which is approximately 6.022 x 1023. Therefore, total electrons in 1 mole of methane, 1 10 electrons molecule, x 6.022 x 1023 molecules small. Calculating this gives us the total number of electrons in 1 mole of methane. Result. The total number of electrons in 1 mole of methane is approximately 6.022 x 1024 electrons. Part 2. Turing. Find A, the total number, and B, the total mass of neutrons in 7 milligauss of 14C. Assume that mass of a neutron, bar 1.675 x 10 to 27 keloe. For this question, we need to determine the number and mass of neutrons in a given mass of carbon-14. Carbon-14 is a specific isotope of carbon. We are given 7 milligauss of carbon-14, and we need to find the total number and mass of neutrons. Calculation. Firstly, determine the number of moles of carbon-14 in 7 milligauss using its molar mass. Next, find the number of atoms of carbon-14 in 7 milligauss. Carbon-14 has 6 neutrons per atom. Result. A. The total number of neutrons in 7 milligauss of carbon-14 is calculated. B. The total mass of neutrons in 7 milligauss of carbon-14, knowing the mass of a neutron, is then calculated. Part 3. Hilai. Find A, the total number, and B, the total mass of protons in 34 milligauss of NH3 at STP. Will the answer change if the temperature and pressure are changed? Now, let's calculate the number and mass of protons in 34 milligauss of ammonia at STP. Ammonia has the molecular formula NH3. We are given 34 milligauss of ammonia, and we need to determine the total number and mass of protons. Calculation. Calculate the number of moles of ammonia in 34 milliliters using its molar mass. Determine the number of molecules of ammonia in 34 milliliters. Each ammonia molecule has 3 hydrogen atoms, each contributing 1 proton. Result. A. Calculate the total number of protons in 34 milliliters of ammonia. B. Calculate the total mass of protons in 34 milliliters of ammonia. Conclusion. So we've solved these questions step by step. Now, regarding whether the answers would change with temperature and pressure changes. Explanation. For questions B and ch, which involve mass and number calculations, temperature and pressure changes would not affect the number of neutrons or protons in a given mass of substance. However, it's important to note that changes in temperature and pressure can affect the volume of gases, which relates to Avogadro's law and the ideal gas law.